Hello, my dear students. Welcome you all. And this is your B V Reddy sir. आज हम कुछ प्रॉब्लम्स कैपेसिटेंस का प्रॉब्लम आज हम डिस्कस करने वाला. चलिए, let's start our discussion now here. Let's see one by one problems. Let's see the first problem. When two or more uncharged capacitors are connected in series across a potential difference. So what they given now here. So two or more capacitors. Let us consider three capacitors. The three capacitors are connected. How they are connected? They are saying here. They are connected in series. How they are connected? Series. They connected. If the capacitors has been connected in series across some potential difference they has connected. The potential difference means this is some supply voltage if I call Vs. This capacitance is C1, this capacitance is C2, this capacitance is C3. Yeah, you can tell me now here. So as we know this KVL, so this is connected to positive terminal here. So this is ये तो positive बनेगा, this is the negative, and this is positive, this is negative, and this is positive, this is negative. Now the potential across this one, this one which I am calling it as what, tell me now here. This potential is a V1, potential difference V1. This potential difference across the second capacitor is V2, and across C3 which is a V3. Right. Now we can apply the KVL in this loop. What is the KVL is the algebraic sum of the potential difference across each capacitor in any closed path. Any closed loop is 0. Now you can tell me now here by KVL. So tell me now here. So this potential which is a V1 plus next V2 plus what, tell me now, V3 minus Vs which is equal to 0. So from this what I can say now here, V1 plus V2 plus V3 which is equal to what, tell me now, Vs. Now you see this thing, first statement what they given. The potential difference across the combination is the algebraic sum of the individual potential differences across each capacitor, isn't it? So ये तो सही ना, tell me the potential difference across the combination. This is the across the combination is what, tell me, algebraic sum of the individual potentials. Right. So option A. So correct na here. Now see the second one B given. Each capacitor carries the same amount of charge. Yes. Now here how the capacitors has been connected here. So the capacitor has been connected in series connection. If I call the charge is Q1 and the charge is what, tell me now, Q2. The charge is what, tell me now, Q3. The supply is delivering a charge of Q to the combinations. Now you see this thing here. The same amount of charge passing through this all the capacitors, right? So here what we can say now here, that is Q1 equal to Q2 equal to Q3 which is equal to Q. So that means each capacitor carries the same amount of charge. Now see the next one. The equivalent capacitance of the combination is less than the capacitance of any capacitors. Yes. Now you tell me, when the capacitors are connected in series, what is the equivalent capacitance? You tell me 1 by C equivalent, which is equal to what, tell me, 1 by C1 plus 1 by C2 plus 1 by C3. So three capacitors considered. So this C equivalent value, equivalent capacitance of this combination, which is less than all the capacitances. It is less than the smaller value. So this is less than C1, and the C equivalent is which is C equivalent value, even it is less than C2 and 𝐶_equivalent, even this value less than C3. So the equivalent capacitance of the combination is less than the all the capacitance. Means we can say the equivalent capacitance is smaller than the smaller capacitance. So that is C is also correct. So now you tell me now all A, B, C are correct now. So what's the correct option now here? All the options. All are correct only. Now see the next problem. When two or more capacitors are connected in parallel across a potential difference. Now the capacitors has been connected in parallel. Capacitors are connected in parallel. Now you tell me now when the capacitors has been connected in parallel, see what's going to happen, you tell me. Let us say this is the supply voltage. Capacitors has been connected in parallel Vs, and this is C1, this is C2, this is C3, right? Now you can see now here, now the potential across each capacitor is, if I call this as V1, and this potential difference is V2, this potential difference is V3. So that means what we can say now here, here V1 equal to Vs, V2 equal to Vs, V3 equal to Vs. That means all the potentials are same. Next, so look at now here, and whatever the charge you tell me here in the parallel connection are charge. If I call the charge is Q, some of the charge may go here, this charge is Q1, some of the charge may go here, this is Q2, and some of the charge will go here, this is Q3. Now if we apply this as a KCL, so look at now here by KCL what I can say. So this is Q is equal to what to tell me now here, Q1 plus Q2 plus Q3, Q1 plus Q2 plus Q3. Now check the options now which will be correct. The potential difference across each capacitor is same, so is correct now. And each capacitor carries the same amount of charge. No. So in case of series connection only charges are equal, but parallel connection potentials are equal but charge is not equal. So then option B is wrong. B is wrong. Next, equivalent capacitance of the combination is less than the capacitance of any capacitors. OB Galatai. In series, so previously series case, now it is a parallel case. In parallel case, the equivalent capacitance which is given as what, tell me, sum of all these capacitances C1 plus C2 plus C3, where the equivalent capacitance C equivalent, which is what, tell me now here, this equivalent capacitance, this C equivalent which is greater than C1, and this is greater than C2, this is greater than C3. The equivalent capacitance of the parallel combination is larger than the largest value, bigger than the biggest value. So but it is given smaller given us, so this is wrong. So only the option A is correct. Next, now see this thing here. The four identical capacitors in the circuit shown in the figure are initially uncharged. Okay, let the charges on the capacitor Q1, Q2, Q3, Q4. Okay, each capacitor given like this. The potential difference across them is given as V1, V2, V3, V4. The switch is thrown first to position 1. Initially the switch is at position 1, Initially switch is at position 1 and kept there for a long time, and it is thrown to position B. Which of the following conditions is true with the switch in position B? Right. Look at now here what they given. I have the four capacitors. All the capacitors are identical capacitor. That means C1 equal to C2 equal to C3 equal to C4. All these values, let us call them as C equal values. Right. Now initially the switch is thrown to position A. That means this connection is established. That means there is no connection for the B. So initially, so that means what is the circuit will becomes, you tell me. Now this is, I have one capacitance. This capacitance is what, tell me now here. Capacitance, all the capacitance values are equal. Right. Now this voltage, they are saying this voltage has what, tell me now, V0. And this capacitance is C1 equal to C only. This connection is established. Now they are saying the charge. Here the charge is Q1. Now you can see now how much the potential difference across this capacitor is, that is V0 only, isn't it? V0 only. Now can you tell me now Q here? So potential difference V0 capacitance, can you tell me charge in the capacitor C1? That is given as what we can say now here, C into V0. This is the charge in the capacitor C1. Now what they did now here, this combination now replaced. Now the switch, earlier the switch is in this position now. Now the switch is shifted to this position. Switch is shifted to this position now here. Now redraw this part here. If I redraw it now here, you can see now here, this thing will happen. What, tell me? All the capacitance values are what, tell me, equal. All the capacitance values are equal. So this is C2, this is C3, and this is C4. Now what they did now here, for this combination we need to find what, tell me? So we need to find the potential and voltages we need to see the relations. Now look at now here. So this whole combination which will be given a supply. Now this capacitor C, it will behave like a source for this. Now how much this voltage has been given to here, this combination is a V0. V0 is given. Now how this C2, C3, C4 connected, series connection. So same charge will flow. This, if I say the charge is Q2 and the charge is Q3 and the charge is Q4, equal amount of charge flow through the each capacitor. Now how this, all the three capacitors now here, these three capacitors are in series, we can find the equivalent capacitance of this combination. So what are the equivalent capacitance of this combination, you can tell me now here, as they given all the values are C only now, this value C, this value C, and this value also C only. So three capacitors connected in series, the equivalent is what, tell me now, C by 3. Now for this combination, they given the another capacitor. So this is the C1 capacitor is given now. Here we have a C1 capacitance is there. This is the C1 capacitance, and this is the equivalent of these three capacitors. How much that value? So this value is a C by 3, and this value C1 is equal to C only now. And initially, so if I call this voltage across the C, which is equal to V0, but this voltage is 0. Now these two are connected connected, then these two capacitors will reach us to the common potential. So can you tell me the common potential here? So can you tell me the common potential here? The common potential V, which is given as what we can say, tell me. So C1 V1 plus C2 V2 by C1 plus C2. So it should be given as what we can say here, C1 V1 plus C2 V2 by what I can say here, C1 plus C2. So how much this value, tell me now here, CV. See, we have this V is a V0 now, tell me. C2, V2 value 0. So C1 plus C2, that is C plus C by 3. So how much will come here? So it will come it as 3 V0 by 4. 3 V0 by 4. This is the common potential after connections. This is a common potential after connections. Now here, so this capacitor, which is V0, 3 V0 by 4. Now you can see now here this combination of capacitors. This capacitor, here the capacitance is here. Now this capacitance, now this C2 value is equal to C. This is C3, which is also equal to C. This is C4, which is also equal to C only. Then how much is voltage going to this, you tell me now here. This overall voltage, which is after connection, that is what I mean of 3 V0 by 4. Now here this voltage, if I call this as a V2, this voltage is a V3, and this voltage is a V4. Now this voltage will divide between these three capacitors. So then how much is V2 value, tell me? That is, since all are equal capacitors, equally will divide. So V0 by 4, V3 is equal to V0 by 4, and this V4, which is also equal to what, tell me now? V0 by 4. Like this, those will divide. Okay. So this charges will divide like this. But they given these values, given V1, V2, V3. V4 is not equal now here. V1 is not equal to this much. V1 is how much here? V1 is a V0. So this first option is wrong. And V1 is equal to, so tell me now here, V1, it should be given as what, tell me here? V1 is a voltage across this first capacitance now here, and that should be given as what, tell me? V1 is equal to V0. And what else you can see now here? Okay, so here this V1 is equal to V1 is equal to V0 when the switch is at position A. But they're asking which of the following conditions is true. Yes, when the switch is in position B, when it is in position B, they are saying that what will be the values, isn't it? So this value is wrong. So we are talking about when the switch is at position B, not in position A. When the switch is at position A, V1 is equal to V0. Now you tell me when the switch is in position B, so this value V1 is how much here? V1 is a 3 V0 by 4. V1 is 3 V0 by 4. So that's why this is wrong. Next one. Now if you find the charges now here, look at now here, what is the equivalent of all these capacitors is a? The C equivalent, which is what, tell me here? Equivalent capacitance, which is equal to what, tell me now here? 3C. Equivalent capacitance is how much? 3C. Now if we talk about the charges now here, what is the Q now here? Q is equal to what we can say? C into V. Q is equal to what? Tell me. C into V. So now you can find out these values now here from this charge. It should be given as what? Tell me. V naught. Now after this connection, so this is, if I say this as Q2 and this is Q3 and Q4, all these charges are equal now, and that should be given as what I can say equivalent capacitance into what I can say supply voltage, that is V. So what I will get to tell me now here, C2 equal to Q3 equal to, and this is Q4, that is given as what now? What is the C equivalent value? That is C by 3 into V. So this means what we can say here, look at now here, Q2 value is what? Tell me now here. So that is 1 by 3 into C into V. Q3 value, this is 1 by 3 into C into V. And Q4 is what? Tell me, 1 by 3 into C into V. And what is the Q1 value we got? You tell me here. When the Q1, when the switch is at position 1, you can see now here. So Q1 value we got it now here. The charge through this capacitor C1. This is, which is what? Tell me here. 3 times you can see now here. This value. So which will get it as what? Tell me here. This thing. So equivalent value. Sorry. Where is this one? Yes. So this value, which is what? Tell me now. C into V now here. So what is the relation between them here? So Q2, which is equal to 3 times of Q1. Yeah. No. So Q2 equal to 1 by 3 times. Q3 equal to 1 by 3 times of Q1. So that means Q1 is equal to what we can say here, 3 into Q2. So you can check the options. So option D is correct. Next. See the next problem. The equivalent capacitance between M and N. We need to find the equivalent capacitance between M and N. We need to find. See this one, terminals we have taken. I need to find the between M and N. So meanwhile we'll give some terminals in now here. Let us redraw the circuit in these cases. So let us call this is A. So in between this and this there is no element, so this is also A only. And this I am calling it as the junction, I am calling it as a B. Now let's redraw the circuit now here. This point I am taking it as a M, and this point I am taking it as A, and this point is a B, and this point is a N. Now see this one here. We have between M and A we have one capacitance. Place that capacitance once again. Yeah, this capacitance value given as C0. All are equal values only. So this capacitance is over. Next between M to A. Now this is also M to A only in a M, and this point is A. M to A we have one more capacitance and place that capacitor. This is how much this value C0. Now this is also over. Next A to B, this capacitance is there now. Place it. Between A to B we have one capacitance, and that is what I'll be now C. Next A to B, this capacitance is also between A to B now here. C0, place it. So this capacitor is C0. This is over. Now A to N. This is A and this N. N means where you tell me now here now. Connect the one capacitor. So I'm placed one capacitor here. This is C0. Next, what else now here? B to N. B to N means here place the capacitor. Now you can see now here how these two capacitors, you tell me how these two capacitors are. These two capacitors are in parallel. These two capacitors are in parallel. In parallel equivalent of them, which is what I can say now, this equivalent is a 2C0. We are adding them. So what about these two capacitors? You can see how these two capacitors are. These two capacitors which are also in parallel. So then equivalent is what I can say, this equivalent is 2C0. Now I am redrawing the circuit again. So this is by replacing the connections. So this is how much is value? 2C0, and this is 2C0, and here this is another capacitance. This value is C0. Next we have another capacitance which we have. This is how much this value? C0, and this is M, and this is N. Now you can tell me now here how these two capacitors now here, these two capacitors which are in series. Series means equivalent 1 by C equivalent equal to 1 by C1 plus 1 by C2. This equivalent value is how much we can say? 2C0 by 3. If I redraw this thing here, and this 2C0 by 3 and C0, these two are in parallel. So that means equivalent will becomes what? Tell me here, 2C0 by 3 plus C0. We can directly add them now. That is how much? 5C0 by 3. Now finally this equivalent. So if I redraw the circuit again, so it will come it as like this. Now this value is 2C0 and this value is 5C0 by 3. Now this is M and this is N. Now how these two capacitors, you can tell me? These two capacitors are in series now here. These two capacitors are in series. In series, what we can say now here, equivalent capacitance is, so that is equivalent capacitance C1 C2 by C1 plus C2. That means what we can say here, 2C0 into 5C0 by 3 by, that is 2C0 plus 5C0 by 3. Simplify this thing here, will come it as what will be now? 10C0 by 11. So this option A. Next one. Take the next one. Equivalent capacitance between A and B. So whenever they given this type of cross connection, so we need to redraw the circuit, then you can easily understand. Look at now here. And this is one I'm calling point junction 1. And this is 1. You see this thing here, this same wire which is connected to here. That's why this is also 1 only. Okay, there is no element now directly connected. This is short path. Now here if I call this is a 2, the same wire which is bringing here connected to here. So this is called it as a 2. Now this point is 2 means between there is no element is there. So this is also 2 only. Now this is 2, the same short is there now here. And this is what I can say here. This is also 2 only. This point if I say this as a 3 and this 3 which is coming and connected here, the 3. All of you first of all this thing cleared. Now we'll redraw the circuit. अभी देखो इधर क्या आएगा इधर. So this point, this thing, and this is A. Now I am taking here this point is here it is a 1 I am taken. I have taken another point. This point is a 2 I am calling, and this point is a 3 I am calling. From 3 we have a B terminal is there. This is B. Now let's place one by one capacitance. Between 1 and 2 we have this capacitance, right? So place it now here between 1 and 2, this capacitance value we have a C. Next between 2 and 1, 2, 1, 1, 2 both are same only. So that's why we are placing the capacitance here. Next. So now this capacitance between 1 and 2. Yes, 1 and 2 means here only now. This point. This is C. Next here 2. And this is what tell me 2 to 3. 2 to 3 means here. This capacitance 2 to 3. And this is 3 to 2. So this capacitance is what we can say here. 3 to 2 here. And this capacitance is 2 to 3. Now this is C, this is C. Now you can tell me now how all these three capacitors are connected. You tell me how all the three capacitors are connected parallel. So equivalent is what we can say 3C. We can simply add them now. All these are parallel. Next, how these three capacitors are connected. You tell me now here. These three also parallel. So parallel means we can directly add them. So how much this value? This is also 3C. Now 3C, 3C. How the 3C, 3C? These two will come in a series. Say 3C and this is also 3C. And how these two here? This is A and B. That is CAB. How these two are now tell me? In series. So that equivalent is what we can say 3C by 2. Next one. Three identical capacitors first connected in series, and after that what they did now here. Yes, and the first and last conductors of the combinations are connected to earth. Okay, a charge Q is given to second conductor of the first capacitor. Yes, for this they given charge. Then they ask him to find the potential of this capacitor. This is C1 if I say. This is C2. Of course, all the capacitance values are equal. We need the potential across the C1 is required. Circuit initially, the three capacitors are connected in series. The three capacitors are connected in series. to a supply. You can see the supply here, the supply which is a V. Now, if we talk about the charge on this one plate, which will be a Q1 if I call this plate, and so this plate is minus Q1. Since the capacitors are connected in the series, same charge will be there in each plate. So here this one charge which is equal to plus Q1, and this side is minus Q1, this side is plus Q1, and this side is minus Q1. First thing, and thereafter what they did, you can see now here. Some charge we have given to this plate. When I given some charge to this conducting plate, see what's going to happen here. Now I will redraw the circuit again. Charge given to the first capacitor only, so the charge on the remaining two capacitors does not affect. And so these two, this is grounded and this is also grounded. Ground means the voltage is 0. This voltage is also 0. When I supplied certain amount of charge to here, some charge we have given, see what happens now here. So here in this capacitor, this is Q1 now here will same. This capacitor minus Q1, this capacitor plus Q1, and this capacitor is also minus Q1. This value is not changes. But what changes you can tell me here? But what changes here, tell me? The charge on the first capacitor, we have given some charge given us, so that's why that charge will affect. Now if I call on this one charge, it should be a Q2. On this one, then obviously the charge is what, tell me? Plus Q2. Now if we observe here, this one, if we apply this KCL for this combination, KCL for this combination, now you can see now here, charge on this plate is in this, that is minus Q2, in this plate is plus Q1, and that should be equal to what element now? Plus Q. Right. So we need to get the Q value. Now when these are connected, this potential which I am calling it as a V1, and this potential which I am calling it as a V2, this potential I am calling it as a V3. Now if we apply the KVL in this loop, we can get this equation. So tell me now the equations what we'll get. So this is plus V1 plus V2 plus V3, which is equal to what, tell me now? 0 now. This voltage 0, this voltage is also 0. Now what is the V1 is a? Yes, V1. Here V1 which is given as what, tell me? V1 means what, tell me now here? This potential is V is equal to Q by C. V1 is equal to Q. Q means how much the charge here it is a? On this one here we have charge, it is what, tell me? Q2. So what I can say, tell me now, Q2 by capacitance values are equal now, all the capacitance. Next, what are the V2 value, tell me? On this one charge is what, tell me now? Q1 by C. This is V3 which is equal to what, tell me now here? Q1 by C. So this is V1 which we got it as what, tell me now here? Q2 by C plus Q1 by C plus Q1 by C, which is equal to what, tell me now? 0. So C will get cancelled. So what I'll get the Q2 value, tell me now here? Q2 is equal to 2Q1, that equal to 0. So that means Q2 is what, tell me? That is minus 2Q1. Now we have the relation of here minus Q2 plus Q1, which is equal to what, tell me now? Q. So then here we need the Q2 required. Q1 is equal to what? Tell me. We can replace now here. Q2 required now. So we need the capacitance of this capacitance. So this first capacitor C1, the charge on this voltage on this capacitor, that is V1, after the connecting grounded, that is given as V is equal to what? Tell me now. Q by C. Q is how much here? That is a Q2. Q2 by capacitance is C. We need Q2 is required. So Q1 is equal to what from this relation now here? We can place it now here. This is minus Q2. Yes, and this value Q1 is equal to minus Q2 by 2, which is equal to Q. So this is minus 3Q by 2, which is equal to Q now here. So that's why Q2 value how much? Tell me. Q2, which is equal to minus 2 by 3 into Q. This is the charge on the first capacitor. So if I replace this thing, potential which is given as what? Tell me now here. 2Q by 3 by C now. So of course capacitance magnitude we have considered. That's why no negative sign. That is V1 is equal to 2Q by 3C. So what's the option you can see? Option C. In the circuit shown in the figure, initially K1, K2s are the switches here. K1 is closed and K2 is open. Let the charge on C2 is Q2. Then K1 is opened while K2 is kept closed. Let the charge on C2 given as a Q2 dash. They are asking to find the ratio of initial charge by final charge. Now the first case, what they given you can see now here. In the case 1, they are saying it as what? Tell me now in the case 1. So K1 is closed. K1 closed. Closed means what? Tell me. This is on. K1 is closed means on. And K2 is what? Tell me. Open. K2 is opened. Open means what? Tell me now here. This is off state. Right. So see that, draw the circuit now here, how it could be a. So first K1 is on. So this is the supply given as how much here? 9 volts given. And this is C. So they given it as 6 now here. So I can write it as 6 micro. So this is 6 microfarads. And C is connected. And this capacitance is how much here? So this is 3 microfarads. Now you tell me now here. And we need the capacitance. This is the C2 now. This is the capacitance. Here we need required things here. Now if I call this voltage across this one, which I say this as V1, this voltage is a V2. We can apply the voltage division rule, VDR, voltage division rule. As we know, voltage is inversely proportional to the capacitance now here. So that means V2, which is equal to what I can say, tell me now here, this one here. So this is 1 by 3 by, what I can say here, 1 by 3 plus 1 by 6 into what? Tell me now, 9. So then V2 value, which will come it as what? Tell me now here. So this is 6 by 9. So this value 6 volts. Now we got the V2 as a 6 volts, and this is the case 1. In the case 2, what they did, you tell me? In the second case 2, what they did here? Now they are saying that now K1 is open, K2 is closed. K1 open. Open means what? Tell me, off state. And K2 is closed. Closed means what? Tell me, on state. Now draw the circuit now here. In the second case, so this is, then first part is open, that does not affect the circuit. Here switch is closed. Here is a capacitance. Here is a capacitance. Now this is another capacitance here. Now this capacitance value, so this is C2. This is the only C2 value of C2. This is how much this value? 3 microfarads. And this is also 3 microfarads only. Now initially this voltage, this capacitor have a voltage. How much the voltage of this capacitor is a 6 volts. Initially this capacitor, this voltage is what tell me now? 0 volts. When the two capacitors are connected, they will reach us to some common potential. The common potential that I am calling it as a V. So tell me the common potential. Common potential V, which is given as C1 V1 plus C2 V2 by C1 plus C2. So you can tell me now here, that is 6 into 3 plus what? Tell me 3 into 0 by C1 plus C2, which is equal to 6 now. That means this value, how much you tell me now? 3 volts. That is common potential is 3 volts. After the second case, here in the case 1, we need the charge across this element. Now this is Q2. Can you tell me the Q2 value here? How much the Q2 now here? Case 1 charge, which is given as capacitance, we know, voltage we know. So this Q is equal to CV now here. Q is equal to C into V. How much this value here? So this is 18 volts. 6 into 3 now. So 18 coulombs. So this is what? Tell me now? 18 microcoulombs. Now whatever the charge here now in this is the Q2 dash. Q2 dash is what? Tell me, the capacitance is a 3 into 3, which is a 9. So this is 9 microcoulombs. Now they are asking to find what? Tell me now here, Q2 by Q2 dash. They are asking to find Q2 by Q2 dash now here. That is how much this value? 18 microcoulombs by 9 microcoulombs, which is equal to 2. That is 2 by 1. So the answer is B. Next one. Find out the charge on the condenser. Condenser is nothing but capacitor across 5 microfarads. We'll find the charge on the 5 microfarads. Look at now here how these two capacitors are now parallel. Equivalent will become what? Tell me now? 7 micro. If I redraw this part, here you can observe here this combination parallel. So this voltage is how much we can say? This voltage is 6 volts now. This voltage is 6 volts. And this whole combination voltage from this voltage is also 6 volts only. Means, and this combination, how much this capacitance is a 3 micro, this is 7 micro. So the whole combination for this, the voltage is how much? 6 volts. Now they're talking about this capacitor. Let us say this capacitor voltage, we are calling it as V1. So you can tell me the V1 value. So I need capacitance is inversely proportional to voltage. Voltage and capacitance are inversely proportional. So what I can say, tell me now here, 1 by 7 by 1 by 3 plus 1 by 7 into total is how much? 6. So it will come it as what? Tell me now here. So this is, if we have simplified, so that is 3 by 10. So this is how much this value? 3 by 10 into 6. How much this value? 2. 3 is 2, 5. So it will becomes V1 value. How much it is? 9 by 5. This is the 9 by 5 volts we got. Now again that means voltage across this 7 micro. 7 micro is nothing but what? Tell me? Combination of two capacitors now. Those are what? Tell me now? 2 and 5 combinations. And this is the combination of two capacitors, that is 2 microfarads, and this is 5 microfarads. And this voltage, the whole voltage is how much? You tell me? 9 by 5 volts. So this voltage also same only, this is also 9 by 5 only. Now we need the charge to this capacitor, right? So charge is given as what I can say here, Q into Q is equal to C into V. That is C value 5 micro into that is 9 by 5. So we'll come it as what? Tell me now? 9 microcoulombs. Next one. The effective capacitance between A and B. Yes, whenever the bridge is given, what we need to do, we'll check for the balancing of bridge. Here, this is C1 and this value is C2, this value C3, this value C4. Now you can check this thing here. Is C1 by C2 is equal to C3 by C4? Yes, satisfying now. So from this what I can say now here, bridge is balanced. If the bridge is balanced, then what we can do? Tell me. Then the charge flowing through this diagonal charge is what? Tell me? 0. So that element is removed now from the network. So if I redraw the circuit now here, then how it could be? Now this capacitance, which is a 2C, this capacitance is C, this capacitance is 4C, this capacitance is a 2C. Now you can see now here how these two capacitors are now. Tell me. These two capacitors are in series. The equivalent is what we can say. Tell me now here, 2C by 3. And these two capacitors are in also in series. The equivalent is what we can say here, 2C by 3. Sorry, 4C by 3. This value is what? Tell me now, 4C by 3. Now this whole combination is in parallel. The whole combination which is in parallel. This is 2C by 3. This is 4C by 3. Now tell me now equivalent capacitance between A and B. So this is 2C by 3 plus 4C by 3. That is nothing but what? Tell me now? 2C. Next. The given E is equal to 90. They are asking here C2 given as 3C1. They are asking the potential difference between P and Q. Now fine. So let us see, this is C1, this is C1. So what is the equivalent of these two, you tell me? That is, what, tell me now, see this now. So C1 by 2. Now this C1 by 2, C2 given us, what, tell me now, 3C1 only given. So these two are parallel now, this and this parallel. So equivalent will becomes, what, tell me now here? So that is 3.5 C1. If I redraw the circuit, tell me now here. Will come like this. E value given us how much? 90 volts given. This value C1. This is how much it is? 3.5 C1. Now then, voltage across this I am finding that as V1. Now here, tell me the V1, which is equal to what I can say here, inversely now here. That is 1 by 3.5 C1. But tell me, C1 plus 1 by 3. This is 1 by C1 plus 1 by 3.5 C1 into total voltage given as a 90. Now you can simplify this thing here. V1, it should becomes what, tell me? So this is what, tell me now? 1 by C1 will get cancelled LCM. And so finally will come it as, this is 90 by 4.5. 90 C1. Okay, by 4.5 will come now. C1 also will get cancelled, right? C1 also will get cancelled. So will come it as, what, tell me now, 900 by 45. So means what, tell me now, 20 volts. That V1 20. V1 means what, tell me now, that is the equivalent of this combination now. So equivalent of these combinations. This combination. This is C2. This is C1. This is C1. So this equivalent is how much here? This voltage 20 volts. These two are parallel, so that's why this combination is, whole combination is 20 volts. And this point is P and this point is Q. And what they are saying here, now these two same equal capacitors, now it will divide equally. So voltage. So here this voltage is 10 volts. And here this voltage is what I can say, tell me, 10 volts. So the potential difference between P and Q is how much? 10 volts. Okay. Yeah. That's for the today's sessions, and we'll see in the remaining problems in the next class. Okay then, see you. Bye bye.